Then dark energy. What do you call as dark? Usually we are very racist, right? Dark. What does dark indicate? Absence of light. Okay, very good. But whatever we don't understand, we call it dark, right? Black magic. So we don't understand what is happening, so we call it black. So same way, we understood, we have proved that the universe is expanding, but we still don't know the reason. We still cannot pinpoint, this is the reason for the universe expansion. So we have said that there is something called as dark energy that spreads throughout the universe and which is responsible for the acceleration of universe. Energy which is hypothesized. Again, we have not proved it. So we know the universe is expanding and we don't know why. So we have called dark energy, which is the reason throughout all the space, which is tending to accelerate the expansion of the universe. The next is dark matter. Okay, so have you seen the picture of Milky Way? Yes or no? Yes, very good. So imagine, I'm not drawing a proper Milky Way, but imagine this is the Milky Way and it is rotating. The Milky Way is also rotating, right? The whole galaxy. Now, we can see that most of the material in the Milky Way are at the center of the Milky Way, and there are very few particles that we can see, or very few bodies that we can see, which are at the outer end of the Milky Way. With our photographic vision, with our ideas, we can see all the matter is focused on the center of the Milky Way. Okay. Now, imagine you take a towel and you rotate the towel. Next, you take a towel, dip it in water and rotate it. Which will move faster? Which will move faster? The water one, right? Which we have dipped in water. So to move faster, you have to have more mass. If you are heavier, you will move faster. Yes or no? But we can see that the outer arms of the Milky Way are moving very fast, even though there is no much matter in this compared to the center of the Milky Way. Now we are confused. Why? So we said that, oh, there is something called as dark matter, which is present at the end of the Milky Way, which is helping them rotate fast. Understood? Simple. So what is dark matter? We believe that they are located in the outer arms of the galaxies, which is making them rotate faster than the center, which we can see all the mass located. Okay. So dark energy and dark matter. Shall I move ahead? Okay. So the next topic we are going to study is antimatters. Antimatters. You would have heard this in your Avengers movies, right? So what are antimatters? So usually we said the opposite of proton is an electron, right? A negative charged particle. But no, every particle or every element or every particle in this universe has an exact opposite copy of it with an opposite character. These are called as antimatter. It is hypothesis. Again, these are not proved. So we again say it is hypothesis. It is hypothesis that every elementary particle, may it a photon, may it a quark, anything has a opposite, a partner particle known as antiparticle or antiparticle. It is hypothesized that every elementary particle in the universe has a partner particle known as antiparticle. The particle and the antiparticle share many similar characteristics. Maybe the weight might be same, mass might be same, but many other properties are exact opposite. So that's why they're called as antiparticle. So their many qualities are exactly opposite. The electron has antiparticle called as anti-electron. So it's not proton that we used to link till now. The charge of proton and neutrons were, proton and electrons were opposite, right? But the antiparticle of electron is anti-electron. They have the same masses, but they have exactly opposite electrical charges. Electron and anti-electron. They have the same masses, but exactly opposite charges.